academic online tutorial. We have been considering the 2021 Waec exam preparatory questions, and today we'll be considering the aspect of distant and bearing. Distant and bearing has become a one of the questions that mathematics 2 set, and it is not negotiable. It's either you see distant and bearing, longitude and latitude. These questions are bound to be set every year. Okay, now we'll be considering some few questions now distant and bearing so as to get your mind prepared for the exam. Now the first question here says 2 sheep leave a harbor of Q. 2 sheep leave a harbor of Q at the same time. One says at a speed of 5 km/h on a bearing of 49 degrees. The other says at a speed of 9 km/h on a bearing of 315 degrees. The 2 sheep stop at the point X and Y, respectively, on the sea after 2 hours. Draw a diagram to show the bearing of X and Y from Q. Now, this is the question on bearing, and we are going to solve it. I want you to know some things. First thing to note here is we are given 5 km/h. They said a 2 sheep leaves a harbor what? Q. A 2 sheep leave a harbor Q at the same time. A 2 sheep leaves a harbor Q at the same time. One says at the speed of 5 km/h on a bearing of what? 49 degrees. And the other says at the speed of what? 9 km/h on a bearing of 319 degrees. The 2 ships stop at the point X and Y. These are the major things that you need to know after 2 hours. After 2 hours. Now, how do you go about this? First list the parameter given in the questions. Solution to the question is the parameters given in the questions. So that the parameters in the questions. Let's list them out. Solution. We have what? Now we have 2 sheep living and harbor Q. It means that the location, they live the same location. Harbor what? Q has still coming to that. This is very, very important. At the same time, so one sails at the speed of what? So if the first ship sails to a point X at the speed of what? At the speed of 5 km/h, and on a bearing of what? The bearing at which is what? It says from Q is 049 degrees. It's 49 degrees. So, and the other says to point what? Y. To point Y on a bearing of what? 319 degrees. 319 degrees at the speed of 9 km/h. A speed of 9 km/h. So these are the parameters. Now I want you to know that these 2 planes get to the destination at S and Y respectively at 2 hours, at exactly 2 hours. So the time required for them to get to this place are 2 hours respectively. 2 hours respectively. So the distance, now this speed, we need a distance here because the first question says calculate the distance between X and Y correct to the nearest kilometer. Now it means that, and we are already given the speed, we have to work out the distance. And how to get the distance from this? I can't get the distance from the speed. There's a formula that links the speed and the time together. The average speed or speed is given as distance traveled all over time taken. This actual will about 10 degrees. Now, what do you mean by that? It means that since we are given 5 km speed here, and the time is 2 hours, then 5 km will be equal to, for x, 5 km will be equal to d all over what? 2. And you cross multiply your d for x, distance for x, or distance for x, and you cross multiply your distance for x, the distance d times 1, and this one will be 2 times what? 5. Having 10 kilometers. So this one is what? 10 kilometers. So the distance covered, the distance that the ship covered from the Apple Q to point X is 10 kilometers. Right, for the 5 will be what? 9 equal to distance D all over what? 2, which is the same time. Remember, they get to what? The same destination. They're going to do what? The X and Y location at the same time. So by cross multiplication, we have D is equal to 9 times 2, which is what? 18 kilometers. 18 kilometers. So here we have this, the second ship cover a distance of 18 kilometers to a point what? Y. Now, how do you proceed from here? We can proceed from here by drawing the what? By sketching or by drawing the diagram to show the bearing of X and Y. Now, since we have our details and our parameters from the question, now is to draw the diagram for the bearing of X and Y from Q. Now, note something that is very, very important here. The first thing is that you must understand the mind and the settings behind the 4 cardinal points, known as what? The north, and the what? The north, the south, the east, and the what? And the west. You can get this very well, you love behind it. Now, this the north. North starts from what? 0 degree. Now, and it goes clockwise, anti-clockwise. They say anti-clockwise, it goes clockwise, like this. It goes clockwise like this. It goes clockwise. So it means that the movement starts from the north in the right direction. So we have this is my right. So it starts moving from 0 to 90 degrees. It starts moving from 0 to 90 degree. 0 to 90 degree, from 90 degree to 180 degree, from 180 degree to 270 degree, and from 270 degree to what? 360 degree. So we start from 0 to 90 degree, 180 to 270 degree. Now, from here now, we could know that between here and here we have our 90. Between here to there we have 1 degree, 2 degree, up to 90 degree. This one we have 91 towards 180 from here, 181 to 277 from here, 271 towards 360. So now, the importance of this is that when they give us a bearing of 49 degrees, they said this first ship leave the harbor Q on a bearing of 49 degrees. It means that well among the cardinal or the quadrant, because this can also be used for quadrant. In trigonometry, this is the first quadrant, second quadrant, third quadrant, and fourth quadrant. But I'm not going to that place today. In which cardinal does this 49 degree bearing falls to? It is between 0 and 90. Because this is 49. 0 and 90 can be found between the range of 0 degree and 90 degree. So it means that the first ship take off between north and east because of the bearing of 49 degrees. So to draw the diagram, you must find a way of bringing the cardinal of bringing the point Q down so as to draw the what? The pairing of x upward. So what do I mean by that? You just try and locate what? Try and locate a point what? Q like this. Draw the 4 cardinal and the point what? Q. So now you start reading this your 0 what degree. And you read from here to our 49. You draw it out like this. You draw it out, that is from about Q to a what? A point X. Remember, this is 10 kilometers and it's smaller compared to 18. So this line will be a little bit smaller. So we have 10 kilometers to point what? X. So this is 0.49 degree. This is 0.49 degree. So the second information given to us here is the second should leave the above Q on a bearing of 319 degrees. There are note that 319 degrees falls in which one? Quadrant, in which cardinal point, in which what section of the cardinal point. So we have what? We have 319 will fall between 270 degrees to 360 degrees, between 270 degrees to 360 degrees, between 270 degrees to 360 degrees, between 270 degrees to 360 degrees. So it means you're going to your bearing lies between the north and the west. The north and the west. So you start reading again, okay, for the what? For the second sheet and leave the apple key. It will have something like this. So what's going there? Very longer than this because this one is 10 kilometers and this one is what? It must show your diagram that this one is long. Very long. It must show because that's one of the things that you want to mark in the diagram. So this one is point what? This one is point. This one is point Y. This one is point Y. So I'm going to so this one is point Y. So from here now we have what? 18 kilometers. So and this place is what? 3 what? 319 degrees. 319 degree, right? Where 319 degree. So now, so we have successfully able to draw down this thing. Then we have a point. We have our point X and Y. Now, question 6. After I have drawn the word said, calculate the distance between X and Y to the nearest kilometer. We are going to connect this point to this point to get our distance. So let's draw a straight line downwardly. So that's our distance X and what? Y. We are still going to be drawing cardinal point later from here. Okay. Now let's of course deal with what? The distance X and Y. How do we get the distance X, Y? That's what the question asks us. How to get the distance X, Y? Now coming back to this. These are diagram bearing. We know that from here to here is 49 degrees. But what about this point? What about this point? Because this 0 is just the way of writing bearing is also 49 degrees. So now to get the angle between here and this point, we know that the total angle here from here to here is 360 degrees. So you know this is 0 degree and this also have what? 360 what? 0 degree and also end with what? 360 degree here. This line is 0 and it also has 360 degree from this point. 0 degree, 360 degree. If you that this also what? If you read from here, is 0 to back to 360. So this is 360. So we just say 360 here minus 319 to get your angle that is left inside. So 360 degree minus 319 will give you angle inside here. So 360 minus 319 will give 41 degree. So this place here is 41 degree. I wish I could use another color marker so you can identify what I'm trying to say. So this is 49 degrees. The angle between here is 49 degrees, so it's 41 degree. So the whole angle here, yes, the whole angle here, the whole angle here, the whole angle here. Now we are going to add it together. So the whole angle that Q is out, the angle Q here will be equal to 41 degree plus 49 degree, which is equal to 90 degree. Oh, the right angle, it's the right angle. So 90 degree, the right angle, right angle, right angle. So we have a right angle here. So from there now, you can bring out the triangle out. So the triangle look like something like this. So this place is your angle 90. So, and this is what y, this is what x, and this is q. This is an angle 90 degree, and this place is 18 what? 18 kilometer. Why this one is what? 10 what? Kilometer. And the question is you look for what? Line what? X, y, x, y, x, y, x, y. That's the process. This is a what? This is a right angle triangle. And in a right angle triangle, you can use two methods. You can either use what? Pythagoras what? Or use trigonometry ratio. What I mean is that you can only use what? Trigonometry ratio is SOHCAHTOA. And the Pythagoras theorem, what Pythagorean rule is what? Hypotenuse square equal to opposite square plus adjacent square. So it means that since you are given what? Two sides of the right angle triangle, you can easily use Pythagoras theorem. But how do we apply Pythagoras theorem? The first thing is to identify the hypotenuse, the adjacent, and the opposite. Now, using what? Pythagoras what? Theorem. Also, we will call it rule, whichever the case, which is hypotenuse square equal to opposite square plus what? Adjacent square. Now, how do you get what is the longest side of the triangle? The longest side of any right angle triangle is what we call hypotenuse. The longest side of the right angle triangle is what we call hypotenuse. The side here, which of the side, depending on the location of the angle. If I consider this angle now, this will be our opposite, and this will be our adjacent. Consider angle x here, this will be our opposite, and this will be our adjacent. So in other words, I want to tap in this our line what? XY, which is our hypotenuse, XY, which is our hypotenuse, is equal to opposite, which is our opposite. Q line QX, so this is square, line XY square, line XY square, QY square, plus what? Plus QX square. And what? Line QX square is the way line. Now this is the vertical line, the way of representing line. Now you have what? Line XY square equal to line QY square plus QX square. Now what does it mean? It means that x, we're looking for what? XY square. Now the XY square we have what? Line XY square will be equal to what? 18 square plus 10 what? Square. So we have line XY square equal to 324 plus what? 100. So we have what? Line XY square equal to what? 424. Taking the square root of both sides. Taking the square root of both sides. Take square root of what? Of both sides. So the square root, this square will cancel the square root. This is not square, square root. So this one is square. So the square root will cancel the square, and the square root of 424 is x value now, and x value now will go to 20.59 kilometer. Now the question says to the nearest what? To the nearest what? To the nearest, draw a diagram. Okay, calculate distance between y, between x and y, correct to the nearest kilometer. Now correct to the nearest kilometer, it means to the nearest whole number. Correct to the nearest whole number. This is approximation sign. Approximation sign. So correct to the nearest whole number. This is 20.59. Please can you see? I hope you see what I'm writing here. So this is what this is 20.59. 20.59 to the nearest whole number. I will approximate this 5 to this place. So making what 21 kilometer. 21 kilometer to the nearest number. 21 kilometer to the nearest what? The nearest kilometer. To the nearest kilometer. 21 kilometer to the nearest kilometer. So that is the first question on our display. That's the first question on our display. If you have any questions, you can please drop your comment and your questions inside the comment box section. So now we just did the first aspect. We've drawn the bearing diagram of x and y, and then we have calculated the distance between x and y. Then we have got 2 of b, say the bearing of x from y, the bearing of x from y, and we get the distance. Okay. So the bearing, let me to clean this place. And the question says, because the view of the asked question says, the bearing of x from y. Please note the question, the bearing of what? X from y. The bearing of x from y. The issue of from is very, very important. We have to look for the bearing of what? X bearing of x from y. Now you are going to look for x and y is what we are concerned with. Okay? Over the diagram x and y, x and y. Where's our x? This is our x, this is our y. But they say the bearing of x from y. Bearing of what? Bearing of x from y. Now the y is what? The major concentration to y from y from y. So bearing of x from y. So we are going to draw the cardinal point on the what? On the y, because the question is the bearing of x from y. So we go back to your y, point y here. So we draw what? You draw the thing here, you draw the 4 cardinal points here. Then we have the north, the east, the south, and the west. Okay. So the things that we need to do here, as we have drawn this, the things that we need to do here. So what you need to do here is that what you need to do here is to look at what the principle of alternate angle that you can use. Okay, for example now, if you check this place very well, this side is alternate to this is alternate to this 41 degree is alternate to this angle outside here. So we have what 41 degree is alternate to this angle 41 here. It's 41 degrees. When I say we talk about alternate angle, whenever we have 2 parallel lines, whenever you have parallel, if you extend this line now, if you extend it and extend this and extend this one, they are called parallel lines. And when you extend 2 parallel lines, when you extend this is the vertical aspect. When you extend it, this side will be alternate to what? To this. So 41, this one is 41 degrees, this one is 49 degrees. So we call it alternate angle. This y. Call it alternate angle. We call it alternate angle. Let me draw this y very well so you can see it clearly. So this one is 41 degree y. They are alternate angle. They are alternate angle. They are alternate angle. 41 degree, they are alternate angle. Okay, 41 degree. So that's the first thing that you need to know. Now another thing that you need to note here is the angle from what? Here, this is your east aspect of it. You need to draw it very well so that you don't get confused. So now this is 41 degree. Now we have to look for the bearing of x from what? We have successfully drawn the cardinal on what? On y. This is the point y. This is the point y. And the first thing we need to check is what? How do I get the bearing in the first place? How do I get the bearing from what? From bearing of x from y. Draw the cardinal point on y. Then we consider the line xy. Xy. This is the line xy. This is the line that connects what? X and y together. That connect x and y together. So it means that we are trying to ask for the bearing of this to this. Bearing of what? This is the bearing of x from y. You can't start reading from the what is 0 degree north. 0 degree north here, 0 degree to where we have line xy. That's just the bearing for where we have what line x, y. Don't forget that this is your y here. X, y. The line x, the line x, y, I should put it here. So you won't be confused. Where is your y? This is y. This is y. This is y. So you start reading from the 0 degree to the point of what? X and y. X and y. That is your what? Your line xy. So this from 0 degree to the point of line xy is what we are looking for. About to look for that, there are a lot of things that we need to do. There are some things that we need to sort out. We need to look for this angle here. Angle theta here. I call it angle theta because when you get this angle theta, you'll be able to subtract it from the whole angle here. The whole angle here. That is it. So when you subtract, okay, you'll be able to subtract what the angle 9. You can also subtract what theta from angle to here. Look at this. There's an angle from here to here. It's it's a technical work. So you need to be very careful. And there's an angle here. Measurement of an angle here too. There's an angle between 0 degree to the point of what? Of YQ here. So whenever you get this angle now, which is 180 minus what? 180 minus 49, which is 180. Now the angle from this angle from here to here is what? 180 minus what? 41 degree. What do I mean by that? This angle here to this place is what? Is you can obtain it by subtracting 180 by removing 41 from 180 because here to here is what? 180. Very interesting. Here to here is 180 degree. Then to get the angle from here to here, we are going to remove 41 degree from 180. So the angle from here to here, the angle here from here to here will be what? Will be around 130. Is 41 degree. I mean, this will be around 1. That is 39 degree. That is 39 degree. Please know that there will be 39 degree. 39 degree. That should be 39 degree. Yes, it will be 39 degree. So it means that the angle between here to this here is what? 39 degree. And to get the bearing of what? Of y, the bearing of, now get the bearing of x from y. The bearing of x from y now, the bearing will now be what? 139 degree minus what? Angle what? Theta. That's how important this is. Very is. I will come again, look at this very well. The first thing is to draw the what? The cardinal on point y because it is the bearing of x from what? Y. And after you have drawn that, then you start reading, you consider the line xy and you start reading from 0 degree north to touch the line. This is our bearing. This is where our brain is. This is where our bearing lies. This line is our bearing. It's our bearing. This black line, we use black marker. This point is our bearing. This point is our bearing. This point is our bearing. But in order to get our bearing, we need for us to get this point from here to this point first. Then to get this from here to here, you have to take 180 from what? 41 degree. And we said 41 degrees is gotten as a result of alternating from here. So this one is alternating to this. So that's why I have 41. So 180, that is this angle in a straight line. This angle from here to here is 180. So 180 from 41 degree, we have 139 degree. Then you take what? Theta. Because from here to here is now 139 degree. So we are going to take theta from what? 139 degree to get the angle outside. So that will be our bearing. So the first thing now is that how do you get theta? Because this is very, very important. Question what? Mathematical 2 says bearing of what? Bearing of x from what? From y. I think I've made my point clear. You need to get 180 degree. You need to minus 80 degree minus 41 degree, which is what? 139. And this 141 degree is gotten as a result of alternate angle. Please don't forget. It's got as a result of alternate angle. And we have the bearing now of x from y. We got what? 139 degree minus what? Theta. Then how do we get theta? That's the problem. That's how we get theta. And we solve for theta. So it's not that hard. So you draw out the what? Draw out the triangle once again. Draw the triangle once again. Something like this. So you have your angle here. And we have the word angle theta here, which is y, this is Q, and this is x. Now in this case, since we're having an angle, we're having 18 kilometers, we're having 10 kilometers, and here we just cutting it to be 20.591 kilometers. Now, you can easily find, this is our hypotenuse. Now in this case, since we're having an angle at what? Y, we are going to use this place is advisable to use trigonometry what? Ratio. Trigonometry ratio, which is what? Abbreviated as SOCA. This is sine opposite over hypotenuse, ka up adjacent over hypotenuse, tan opposite over adjacent. Which of these are we going to use? This sine, is it cos, is it tan? This one you are going to know. This one angle theta. The side facing here, this is the side facing the what? Theta, we call it what? Opposite. This is the side facing the what? The angle, we call it opposite. Why this angle, why the right angle is staying with what? The angle, when they are standing side by side to each other. Side by side, we call it what? Adjacent. Not opposite, but adjacent. This is the hypotenuse. Now, since these two parameters are given questions, it's advisable to use these two parameters, not to use the one you obtain for yourself. Peradventure you made a mistake, you don't know. So it's advisable to use the parameter given from the question. So 10 kilometers and what? 18 kilometers. So it means opposite over what? Adjacent, which is tan theta. So we have what? Tan theta, which is opposite over what? Adjacent, is equal to tan theta is equal to 10 all over what? 18. So if we command tan theta, it will be equal to 0.5556. So you take the tan inverse. You take the tan inverse of what? Both sides. Take the tan inverse of both sides. Theta is equal to tan inverse of 0.5556. When you take the tan inverse, you are going to get around what? Going to get around 18 points. 18 point, I think 18 point, and recheck with 18 points. Check the calculator aspect. Get. So you are going to get 29. 29. Point 056 degree. It's very, very 6 degree. But the question says find the bearing correct to do it. So you need to approximate it. So we just get your theta. Then your bearing now. Remember that your bearing of x from y is equal to 139 degree minus what? .what? 139 degree minus, we all said, okay, 139 degree minus 139 degree minus, yes, 139 degree minus 139 degree minus 19.29 point what? 29.056 degree. So when you minus this, what you get? You are going to have what? 139 minus what? 129.056, so this one is 000. So 1998. So you borrow 1 from here. So this one will be, this one will be 4, 9. This one will be 4. Then this one is also 4. This one is 9. Then this one is 80 minus 9 is 9. This is your calculator. This one is what? 3 minus 1. We have what? 3 minus 1. So you have already borrowed 1 from here. So this one will become 2. Borrow 1. This one is okay. So borrow 1 will become 0, 1. Please use your calculator to confirm this. But that's the answer. This 10 minus 6, 4. This is what? Also 4, 9. If borrow 1 before it's from 18 to 1. This is 109.944. So approximately to what? It said bearing of x and y correct to the nearest degree. So the nearest degree now. To the nearest degree, approximately to the nearest degree. You have what? You can approximate this one to this one. This one becomes 0. And you approximate this one will become 110 degree to the what? Nearest. 110 to the nearest degree. The nearest what? Degree. The nearest degree. That's the bearing of x. Bearing of x from y to the nearest degree. The last question says, sorry for cleaning this. If x change course and sale, I think that's the question here. If x what? If x changes what? Course and says, if x changes course and saves to, if x changes course and saves to 4, then change and says to reach what? 1 for 4 hours and says to 4 hours to reach what? If x changes course, now what I'm going to do that in this x now, membership is exactly changing course to from here, from A to what is the x now that is here, the second sheet that is in x, or the first sheet that is in x. If we change this course, we can only decide to go and meet what. And the distance covered for the ship to reach y is what? The distance, the time taken for him to cover the distance between x and y is 4 hours. So what I'm trying to say is that when this x, when this x is ship at this x changes course to go and meet what y, the time it uses to change that course to get to y is 4 hours. Then I say calculate the what? The correct to take significant figure. Its average speed. Its average speed. So we are going to get, you have to go calculate what? The average speed. The average speed. The average speed. The average speed. And how do you get that? The average speed. The average speed is just given. The average speed is given as what? That's this Roman C. Average speed will be given as distance covered. Distance covered is you will see that distance covered between what? Distance covered between x and y. Distance covered x, y. That's 9xy. Distance covered xy. Distance covered xy. All about time what? Time taking. Distance covered xy. All about time taking. So what do we mean? What do we mean? That is our speed. So how do we get our distance cover? Our distance cover is been calculated from the first question. We said xy is what? It's 20.5. So this is 20.59 kilometer. All over. How many hours given now? For 4 hours. The time given now is now 4 hours. 4 hours. 4 hours. So we now have what? When you divide this, you are going to get what? 5. 4 in 20 is what? 5. And 4 this is 1. That one 4 in 19, you have another what? 4. So approximately to this significant figure, this one should be 1.4. Maybe what? This one is 1.4. 5.147. 5.147 kilometer per hour. Use your calculator to get this. We are going to get 5.147. 5.7. So now approximately to three significant 1, 2, 3. 1, 2, 3, 1, 2, 3. So you have 1, 2, 3. So it means what? Approximately it will be 1. This is the third significant, and this is 7. Approximately it will be 1.15 kilometer per hour. 1.15 kilometer per hour. So kilometer per hour. Kilometer per hour. So that's that. That's kilometer per hour. Kilometer per hour. So that's that about 2020 distance and bearing. Here we didn't use sine, but we didn't use cosine because the triangle given or the triangle obtained from the diagram of the bearing gave us a right angle triangle. That's why we use Pythagoras theorem, and we use what? Trigonometry, because it's a right angle triangle. There are a lot of times that we use sines and cosine to solve what? Solve distance and bearing. Yes, it's very true. But in this case, we are given a right angle triangle. And join me in the next subsequent class on how to use sine rule and cosine rule to solve what? Distance and bearing. I come back still on what? Distance and bearing. Still on distance and bearing. The second question here, it says that 3 times A and B, 3 times A, B, and C are situated so that line AB, that is distance AB, 60 km, and distance AC is equal to 100 km. The bearing of B from A is 060 degree, and the bearing of C from A is 290 degree. Calculate one decimal place the distance BC and the bearing of B from C. Now the first thing here is to what? As always, so let's do is to align the what? The parameter given or the what? Information given in the questions. We have 3 tan A, B, and what? C. Then we have tan A, B, and C. That is the point of location A, B, and C. Now, and the distance between tan A and tan B is 60 what? Kilometer. The distance between tan what? B, tan what? Tan A, and tan C from the question is 100 what? Kilometer. 100 kilometer. Then they said the bearing of what? The bearing of P from what? A. Bearing of tan B. Bearing of tan B from A. Bearing of tan B from A is equal to 060 degrees, 60 degrees. And the bearing of C, the bearing of tan C from what? From A. The bearing of tan C from A is equal to what? 290 degrees. The bearing of what? Tan C from A is equal to 290 degrees. The bearing of tan C from A is equal to what? 290 degrees. Then one of the things we want to do next, you have already aligned the word parameters. The next thing is to sketch the diagram. You have to draw diagram in every distance and bearing what question you are given. You are not to do it without a diagram, because diagram carry marks. Please don't tell me, here you are not stating that whether you should represent the information on the diagram, but it's compulsory and necessary for you to draw the diagram if you want to get it correctly. So now, we said that there were 3 terms, A and B and C, are stated in a particular place, in a particular position, in such a way that the bearing of tan B from A is 60 degrees. The bearing of tan B from A is 60 degrees. Now the interpret this. The bearing of what? Of tan B from A is 60 degrees. Now tan B from A. Tan B from A. That's what I'm emphasizing on that. Bearing of tan B from A. Now it means that we are going to draw the A cardinal first. The A cardinal first. So the A, draw the position of what? A. Position of A, we are going to let it come down because we are going to draw something. So we have point A here, tan A here, and from tan B from A is 60 degrees. So we have the north and the what? East, because 60 degrees form between 0 here and what? 90 degrees. So 60 degrees will be around here. 60 degrees to B. So it's what bearing of B from A. So it means that the point B, so the distance between A and B, I will give the distance between A and B will be 60 kilometers. So the distance between A and B, this is our B, because they said this is on the bearing of 60 degrees to B. So it means that this is 60 degrees and it is 60 kilometers apart. Because AB, and it's AB, stand AB 60 kilometers. Now let's look at the bearing of tan C from also what? A. And A is what? Is 0 degree here. We have what? 190 degrees, we have what? 180 degrees. So it's 270. Back to what? 360. Now between that 270, 290 degrees between here. So you draw it out. So it means the bearing of tan C from A 290 degrees, which is going to be here, and you draw it out. Why is it longer? Why did I draw it much longer? Because they said AC is going to be your point C. So AC is equal to what? 8C is equal to 100 kilometers. So it will be longer than the other one. So everything must what? Every diagram must have a reason why you are doing. There must be a reason why you are doing anything in mathematics. There's no reason behind it. Please don't do it. So this one is 100 kilometers. So we have what? Our point C here. Our point C here. It's 100 kilometers. So now I've successfully drawn the diagram. So I've successfully drawn the diagram. So this just I've successfully drawn the diagram. Next thing is to what? Remember that This from here to here is 60 degrees. Then from here to here is 290 degrees. It's very essential to take note of that. Because from this place to this place is 290, and from this place was 60 degrees. Now, the question says the distance BC, so you need to connect C and B together. This distance was BC, just like the previous questions that we did. But not all questions look like this, or diagram look like this. No, we just mean that the two questions seems to have the same diagram, so to say. So now, we have what? This 290 degrees. So we have this. Remember that this is 0 degree and also what? It turns in 360 degrees. Just what happens 360 degrees. To know the angle between here and here, I want to say 360 degrees minus 290 because from here to here is 290 degrees. So 360 degrees minus 290 degrees. What do we have? We have 70 degrees. So this place here is 70 degrees. It's 70 what? This place is 70 degrees. You have to be careful. This 70 degrees is just 0. It's just indicating that this is 0 cardinal point. So let me clean it. So now we have 70 degrees, I have 60 degrees. Add it together, 0, 60 degrees, 60 degrees. 60 degrees plus 70 degrees, 70 degrees plus 60 degrees, 70 degrees plus 60 degrees. What do you have? This whole angle here is 130 degrees. It's 130 degrees. 70 degrees and 60 degrees, or you add them together, it's going to give 130 degrees. Now, from here now, we can proceed to get our BC. Since we know this side, and note the angle. Now in this case, it is not the right angle, just like the previous video that I previous examples. It is not the right angle. This is 130 degrees and it's not the right angle. The right angle is an angle of 90 degrees. So in this case, we are not going to use what Pythagoras theorem, but rather use cosine what? Why am I applying cosine? Because two sides were given and the side we are looking for, the angle of the side we are looking for was given. The angle of the side that we are looking for was given. What do I mean by that? Let's sketch out the diagram first. Sketch out the diagram first. We have something like this. Now the angle here is 130 degrees. This is 60 what? Kilometer. This is 100 what? Kilometer. This is what? C, A, and what? B. Now, look at this. You are doing side what? This side. Now, remember, look at this. These capital letters. And these are called angles. These are angles. Angles are represented in capital letter. Now, the side facing or opposite, or what? The side that is opposite each angle is denoted as what? Small letter of the angle. Now, for example, now, this side is opposite this angle A. This small letter A. This side is opposite this angle what? C. This side is opposite to this angle C. This is small letter C. And this side is opposite to this angle B. This is small letter what? B, that is side B. So this is side A, side B, and side C. Now, cosine will say that whenever we are given two angles and one side of the angle, the one side and the side that we are looking for, the angle must also be given, for it must be applicable. Two sides must be given, and the angle of the side we are looking for must be given. So this place, cosine rule is very, very applicable. Cosine, what is cosine rule? Cosine rule is this. It's stated as follows. Cosine rule states that since we are looking for A, side A square. Side, remember that side A is what we are looking for because side A represents what? BC. Please note that line distance BC represents what? Side A. So meaning that A square is equal to B square plus C square minus 2AB cos, B square plus C square minus 2BC cos what? A cos A. A square equal to B square plus C square minus 2BC cos A. Now, where our A represents what? Our A represents what? BC. We have BC square is equal to what's B? 100 what square plus 60 what square minus 2 divided 100. 60 cos, what is your height? Here is 130 degree. 130 degree. So we have what? Our BC square equal to 10,000 plus 6 square is what? 3,600 minus 2 times this has 200 that's what? So we have 12,000 minus 12,000 times now cos 130 is forced in the second quadrant, so we are going to have minus something. So minus, let me quickly check that. Minus cos that is minus 0.6. If I press your calculator, I don't get minus 0.6428. Now we have what? We add this one together now. 13,600 minus times minus, we have plus, minus times minus, we have plus, so minus times this minus will give you plus. 12,000 times 0.6428, we have 770.26. So that's that amount. So so add it together. I want to have like BC square equal 21,006. So take the square root. Now first I have BC square equal 21,313.6. So then BC is equal to 145.991 kilometer. Now, for 991 kilometer, so approximately to 1 decimal place, so line BC, or this time BC is equal to 141. This one is 1 decimal place. This is the first number after decimal place. Then we consider a number after decimal place up to 9. According to the 9, this one will become 10. This one is 10. Can't leave it like that. So we add it to what? 1 add to this one becomes 6. 1 plus 5 becomes 6. 1 plus 6 kilometers to 1 decimal place. So now according to 9 become 10. You take it as 1 and add it to what? 5. Go 146 kilometers. 146 kilometers to 1 decimal place. So the second question is the bearing of B from C. That is one of the big question of this. The bearing of B from C. Bearing of B from C. So the bearing of B from C, initially we have the diagram. Okay, going back to the diagram, we have our C here. So we have our C. Now, if we have our C here, then we are going to draw what? We have, these are diagrams. Go back to what? The bearing of what? The bearing of B from C. That's the second question. The bearing of B from C. Now, note the word from what? C. So it means that C, the bearing of B from C, I'm going to go to the point C and draw our cardinal point on it. Our cardinal point on it. So we are going to have something like this. So we have C. Now, what does it mean by what? The bearing of B from C? it means that you start reading from 0 down to what? To meet what? B. From 0 on C, 0 degree, in the clockwise direction to meet B. That is line B and C, the line that connect the B and C together. So this is your pairing of what? This is your pairing of what? Your pairing of B from C. But how do we get this? How do you get it? So you have to get, first time, we have to get from here to here first. And you have to get from here to here first. And you know, so you can take from here, so you can take it from here to here. Usually when you get from here to here, you need to get from here to here first. When you get from here to here first, then you get this one, the angle here. When you get the angle here, which I will represent it now, you are going to supply this angle from this bearing from here to here. From what? You take theta from this angle to get this. It's just as simple as take theta from this second angle here to get what your bearing that we're looking for. Now, but how do you get this? You need to consider this also. 70 degrees is alternate to this. It's alternate to this angle 70 here. It's alternate to this angle. It means this and this are alternate angle. When you look at something, when the alternate angles are angle like they are two parallel, and when you have parallel like this, this is what it means. This angle is equal to this angle. This is what alternate angle. Now, to now get the angle from here to here, the angle from here to here, we are going to say 180. This is 180. The whole journey from here to here is 180. So 180 minus 70. 180 minus 70 is equal to 110 degree. So the bearing we are looking for now will have a 110 degree minus what? Theta. So what am I saying is this? Is that 180 degree minus 70 degree will give us 110. And 110, the bearing of B from what? C will be equal to 110 degree minus the theta. Now, how do we get the theta? That's the next law of action. How do we get it? We can only get theta from what? We can only get theta. We need to get theta. We need to draw the triangle again and apply the principle of sine. So we have what is A, B, and what? This is sorry. This is A, B, and what? C. We have this A, B, and C. The opposite side here is what? The opposite side of the angle here, this angle 130 degrees is what? A. The opposite side of angle B here is what corresponds. The opposite side of angle C here is what corresponds what? C. And remember, this is what? 100 kilometer. This is 60 what? Kilometer. And this one is has been calculated to be what? 145.991 kilometer. So to now calculate this, we have something called sine rule. We have to look at this. List out the parameters, and then we'll apply the principle of sine rule. Now the A here, the side A here is 145.991 kilometer. Angle here is equal to 130 degree. 130 degree, you can see. Angle here. Then side B is 100 kilometer. Angle B, we don't know. That's not our concern. Don't know. We are not doing angle B, so we need to write it. But now side C, we still have 60 kilometer. So we are looking for now is we are looking for this angle theta, which is angle what? C is continuous because it's what we are looking for. Angle theta, angle C is same as theta, which is unknown. That's what angle C, the capital letter C is of our business because it's what we have to look for. So now it's one of the things that we use to look for our bearing. So now How do you do this one? How do you find this one? You relate, you have something called sine, which is A over sine A equal to B over sine B equal to C over what? Sine C. But this time, it's not every time I'm using this theory because this theory cannot be applicable at the same time. You already relate two together. Now, but from here to here, we are already given the angle of this and the side of this. We are already given side of B from this question, from this diagram. We don't know the angle of B, so B is not applicable. So rather relate what this A, because we are given the side, we have known the side and we have known the angle. Can relate it to C that we are looking for. So we are going to relate A over sine A equal to C all over what? Sine C. So we now have what? 145.991 all over sine. What is our A? A is 130 degrees equal to C. The 60 kilometer all over sine theta. You see the same as what we are looking for. So we cross multiply. So we have 145.991 sine what? Multiplied by sine theta equal to 60 times sine 130 will give us 0.7660. 0.7660. Now divide both sides. Divide this by what? 145.911. 145.911. So this one cancel this. Sine theta, when you press your calculator very well, I think they have 0.341, so 0.314, so take the sine inverse of both sides, 0.3148. So we have theta equal to 18.348 degrees. Now these are what theta. You remember that I'm looking for the bearing, therefore the bearing of C of B from C is equal to 110 minus 18.348 degrees, because we say 110 minus theta. Theta is what? It was so we have our what? Our answer to be what? Your minus 18, that will be 1 minus 18 from the denominator. Minus 18, let's split together. 110 minus 18. So we get around 18. What do you do? Because your calculator is going to be around 91 points. I think the value here, 91.652 degrees. So 91.652 degrees. So approximately what now? To one decimal place, this one is what? 6, this one is 5. You can take that one, add one to 6, so that's 81.7 degrees to one decimal place. So that's that. I'm going to bring this one up. So that's the answer. So the bearing of B from C is equal to 91.07 degrees to one decimal place. If you have any question as regards to bearing and distance, remember to drop your questions, comments, and remember to subscribe to this YouTube channel for subsequent videos on another topic like measuration, quadratic equation graph, and so on and so forth. We love you. Thanks for watching. God bless you.